Hello viewers, welcome back to Snap's Let's Learn Academy. In previous lecture we had discussed about the threads. We have discussed the single threaded process and multi-threaded process, and also we have seen the multi-threaded process benefits. So what is the multi-threaded benefits? We have already discussed. So if you have not watched the video, so go back and watch that video. Coming to multi-threading models, now in this lecture, so we will understand this multi-threading models. In multi-threading models, uh, in generic sense, we have seen the threads so far. However, the threads may be provided either at the user level or at the kernel, level. So therefore we have two types of threads when we talk about the threads. So there is a user thread and kernel thread. If we talk about the user threads, so user threads are supported above the kernel and managed without the kernel support, right? And whereas the kernel threads are which is supported and managed directly by the operating system, right? Operating system, virtually all contemporary operating system like Windows, Linux, Mac iOS support kernel threads. So ultimately the relationship must exist between user and kernel threads. So now we will understand and we will find some of the common ways to establish a relationship among these user thread and kernel thread. So we have three common ways of establishing such relationship, that is many to one model, one to one model, and many to many model. Now let us discuss the first one, that is the many to one model. In many to one model, it maps many user level threads to one kernel level thread. Now if you see this figure, in this figure there are many user level threads and one kernel level thread, right? So this many to one model maps many user level threads to one kernel thread, and thread management is done by the thread library in user space, so it is efficient. Now, however, the entire process will block if the thread makes a blocking system call. Means one of the thread makes a blocking system call. What happens? The entire process will get blocked, right? Entire process will get blocked. So this is the disadvantage, right? This is the disadvantage. And also because only one thread can access the kernel at a time, right? Only one thread can access the kernel at a time. If you see, there is only one kernel thread and we have multiple user thread. So only one thread can access the kernel thread at a time. Multiple threads are unable to run in parallel or on multi-core systems. So we cannot do the parallel execution, right? We cannot do the parallel execution because there is only one kernel thread and multiple user threads, right? Only one user thread can execute in the kernel thread, or we can say that only one user thread can access one kernel thread at a time. So therefore it is not a efficient model in a multi-threading model, right? So many to one model is not efficient model. So let us go to the second one and let's find out whether the second one is efficient or not. So in one to one model, right? In one to one model, it maps each user thread to a kernel thread. Means if you see there are multiple user threads and multiple kernel threads, and each user thread is mapped to one kernel thread. Now it provides more concurrency than many to one model. Means whatever the disadvantage we had in the many to one model, because many user threads are there, only one kernel thread is there, so we can eradicate that disadvantage in this one-to-one model. So this one-to-one model provides more concurrency than many-to-one model by allowing other threads to run when thread makes a blocking system call. Means any one thread makes a blocking system call, then also other thread can run as usual. It also allows multiple thread to run in parallel on multiprocessor. So it allows multiple threads to run in parallel on multiprocessor. If we have multiple processors, in multiple processors we can run multiple threads. Now it has some issue also, like creating a user thread requires creating a corresponding kernel thread, right? So when you create a user thread also requires to create a corresponding kernel thread. So this is the drawback of this model, right? And large number of kernel threads may burden the performance of a system. See what happens when large amount of kernel threads are created, so we can degrade the performance of the system. So it is a burden to the system and the performance may get degraded. So the Linux along with the family of Windows operating system implement this one-to-one model. So it has some advantages, and also there is a performance degradation or performance burden on the system if we create them many kernel threads. That is only the drawback of this model. Now coming to the third model, that is many to many model. So now if you see this figure, there are many user threads, right, and many kernel thread. It is not one to one. If you go back and see this figure, so for each user thread one kernel thread is created and it is associated with that user thread. But whereas coming to this model has multiple user threads and multiple kernel threads. Now if you see in many to many model, it multiplexes many user level threads, right? It multiplexes many user level threads to a smaller or equal number of kernel threads. So smaller or equal number of kernel threads. So the number of kernel threads may be specific to either a particular application or particular machine. Means the number of kernel threads may be specific. It might be specific for either for a particular application or a particular machine, and this model allows the developer to create as many as user thread as necessary, and corresponding to the kernel thread can run parallel on multiprocessor. So this benefit we can get in this many to many model. And also when the thread performs a blocking the system call, even the kernel can schedule another thread for execution. Means one of the thread call system blocking call, if it block the system, even though also the kernel can schedule another thread for execution. So that is the benefit of this many to many model. So whatever the disadvantage we had in the one-to-one model and many to one model, so those are eradicated. Even though one of the thread performs a blocking system call, then also the kernel can reschedule or it can schedule another thread for execution. Now coming to this hyper-threading or simultaneous threading. So hyper-threading system allows their processor cores resources to become multiple logical processor for performance. It enables the processor to execute two threads or a set of instruction at the same time. Now what happens in hyper-threading? Hyper-threading which enables the processor to execute through two threads or set of instructions at the same time. Since the hyper-threading allows two streams to execute in parallel, it is almost like having two separate processors working together. Okay, now understand this hyper-threading by the example. Assume that we have a CPU with 2 cores and 4 logical processor. So what happens then? Those 4 logical processor can execute 2 actual processors simultaneously because we have 2 core. Let us see the example. This is the snapshot of my laptop. Now you can see my processor name is Intel R Core i3, right? So this is the processor name. This is the processor what I have in my laptop. Now if I see the CPU, my CPU has 2 core and 4 logical processors, right? 4 logical processors. Now what is the meaning of this, right? As we are talking about this hyper-threading and simultaneous multi-threading, right, which allows their processor cores resources to become multiple logical processor for performance, means this hyper-threading allows the system to create more logical processor, right? So already we have 4 logical processors and 2 cores. It means that physically we have 1 CPU and 2 core and 4 logical processor. So actually it execute 2 processes simultaneously. The 4 logical processes are result of hyper threading, which allows each core to simulate 2 logical processors, but they share the same physical resource of the core. Means the physical core, the CPU has 2 physical core, right? CPU has 2 physical cores and each with its own processing unit, and we have 4 logical processors. That is, hyper-threading enables each core to appear as 2 logical processor to the operating system. So while execution, the operating system see the 4 logical processors, the CPU can only execute 2 true processes simultaneously. The logical processors allows for better utilization of the core by switching between tasks quickly, but they don't offer the same performance as having more physical cores. So this is the meaning of this hyper threading. So hope you understood this concept of this multi-threading models. So thank you for watching.